Well, yes, friend, now I will tell you about chain reaction in nuclear fission. Chain reaction in nuclear fission. I told you that number of atoms per gram is very large. And if we have sufficient mass, there will be a good number of 92 uranium-235 or whatsoever the isotope is chosen. So what is the chain reaction in nuclear fission? When uranium-235 captures a slow moving neutron, it splits into two nuclei of comparable mass. When uranium-235 captures neutron, it splits into two nuclei of comparable mass, krypton and barium, and emitting two or more neutrons. So here three neutrons are shown. These neutrons are further, they may be captured by the nearby uranium nucleus, and which further get fission producing two nuclei and more neutrons. This way, these fast neutron will continue to fission more and more nuclei. This reaction is called nuclear chain reaction. Here, since number of uranium nucleus getting fission will increase exponentially, so the whole mass of uranium present there get fission in very small interval of time, and a tremendous amount of energy will be released, which will be explosive in nature. And this is the principle of nuclear bomb. And if the reaction continue, then it is called uncontrolled chain reaction. If we can control, means we allow a certain number of radionuclei to get fission, then that is called controlled chain reaction. That is called controlled chain reaction. Controlled and uncontrolled chain reaction. If the fission, number of fission continue to take place, then in very small interval of time the whole mass gets fission and energy release is very large, and this fission is called uncontrolled chain reaction. This uncontrolled chain reaction takes place in nuclear bomb. If we anyhow can control the chain reaction, means we allow a fixed number of we allow a certain number of uranium nucleus to get fission in a given time, then that is called controlled chain reaction. And controlled chain reaction is the base of nuclear reactor. In nuclear reactor we use a controlled chain reaction. Then how can we control chain reaction? Well, that is another matter. I think I need not to write here what is chain reaction in nuclear fission. I am repeating again. When a uranium nucleus captures neutron, it is split into two lighter nuclei of nearly same mass, producing three more neutron and energy. These newly born neutrons are further able to do fission away. Here krypton, barium, Now it is another nucleus of uranium-235. Newly born neutron strike it, get captured here, and these nuclei split or do fission reaction, producing 3 more neutron and this also. And this way, the newly born neutron will continue to fission the more nuclei of uranium, and a chain reaction is set up. Since in this chain reaction number of nuclei get fission increase exponentially, so in a small time the whole material may get fission and tremendous amount of energy will be released. That will be in one sense explosive and destructive, and this is the principle of nuclear bomb, atomic bomb. Now if anyhow we can control, the control can be done by using some material which can absorb some neutrons which are born by fission, and that material is cadmium rod. Cadmium absorbs neutron easily. Though if we allow a fixed number of fission taking place every time, then that reaction is called controlled chain reaction. Now there is difficulty in maintaining chain reaction. It appears very fine, okay, by once fission has taken place, we can get fission very easily. No. There are two main difficulties. There are two main difficulties in maintaining the chain reaction. In nuclear fission. Two main difficulties. What are those? Number one, the neutron produced here has large amount of energy of nearly 2 MeV. 2 million electron volt energy possessed by these newly born neutron. These fast moving neutrons are not absorbed by uranium-235. I told that natural occurring uranium is a mixture of isotope 238 and 235. I have told you the ratio is 145:1, or you can say only 0.7%. 0.7% is the mass of uranium-235 in a natural occurring uranium. These two isotopes remain together. We can't separate them by chemical reaction. Why? Because atom number same, so their chemical properties are same. So it is not easy to separate. Okay, let us extract uranium-235 separately. They will be found together. एक साथ ही होंगे. So these two MeV neutrons get scattered from uranium-238, get scattered by uranium-238 nuclei, and in that scattering their energy reduced to 1 MeV, and the neutron of 1 MeV are absorbed by uranium-238 without doing fission. I hope you are getting my point. I told you that these neutrons produced by the fission of uranium-235 possess energy of 2 MeV. And there is a big number of, large number of nuclei is 238. Uranium-235 is very small in number, only 0.7%. और in the ratio, अगर mass ratio है तो 145:1. These fast new neutron produced get scattered. You know what is scattering? They collide and get move away from this. In that process, the energy of fast new neutron is reduced to 1 MeV. And these neutrons of 1 MeV are absorbed by uranium-238 and without doing fission. Absorption of 1 MeV neutron by uranium-238 does not cause any fission. So, uranium-235 can fission only when neutron have energy of 0.03 MeV and the neutron energy value of neutron is 0.03 MeV, or this also. This 1 MeV neutron can be absorbed by uranium-235, can fission be made, but their number is small. The number of uranium-235 is small. So nuclear fission chain reaction will stop. Further, uranium-235 can easily get fission if the energy of neutron is this. Then how to slow down these neutrons? Kinetic energy of these neutrons is nearly 2 MeV. So how to slow down them? They are chargeless. Electric field cannot retard them. You know, in electrically charged particle actions, force retarding force can be reduced, but so we use head-on elastic collision. Head-on elastic collision. What is that? When two particles collide, if the kinetic energy momentum is conserved, then that is called elastic collision. And you might have learned in class 11, जरूर पढ़ा होगा आपने कि when two particles of nearly equal mass collide each other, then they interchange their velocities and hence they interchange their kinetic energy. So the fast neutrons are slowed down by passing them through a material having atomic masses nearly that of neutron. Water has hydrogen H2O. If we pass these fast neutrons of 2 MeV through water, then the neutron after colliding with hydrogen almost come to rest and their energy reduced to 0.03 neutron MeV, electron volt, sorry. MeV, sorry. 0.03 MeV. Electron volt, sorry. Electron volt. These neutrons are called thermal neutrons. Why they are called thermal neutrons? In kinetic theory of gases, you have learned that kinetic energy per molecule per particle 3/2 kBt. So room temperature, at room temperature, liquid molecules like water have this much energy. So slow moving neutrons which have this energy equal to the kind energy of molecules of liquid or gas at room temperature are called thermal neutron. So thermal neutron can be obtained by passing them through a material which had atoms or molecules of the size of mass of neutron. These materials are called moderator. Water, heavy water, graphite are moderator. Apsara nuclear reactor in Bombay, Apsara nuclear reactor use water as moderator. Graphite now is not used because graphite itself is combustible. So when the temperature of nuclear reactor goes beyond a certain value, graphite can get combustible and produce more heat. And there one dangerous accident occurred in Chernobyl in Ukraine have article. So moderator are the material which slow down the neutron, fast neutron by head-on elastic collision. So this is why the energy can be reduced. This difficulty can be removed by slow down the neutrons by moderator. The neutron of 2 MeV energy are slowed down by moderator and but problem is there कि uranium 235 is small in number. इसको भी डिस्कस करेंगे. But if there is sufficient number of uranium 235, then chain reaction can continue. Now second fact, since fast the newly born neutron, second difficulty क्या है? Difficulty number 2. These fast moving neutron can before absorbing by uranium 235 to 38 travel a distance more than 10 centimeter and then get absorbed. So if size of the material is small, then these neutron will escape the material and hence nuclear chain reaction will stop. If size of the fissionable material is less than a particular size, which is also called as critical size, then fast neutron will escape from the material and no further nuclear reaction fission will take place. So this is another difficulty which can be overcome by having a particular size and a visual critical size. Actually, there is a ratio K. It is equal to number of fission divided by number of fission by neutrons of one generation. One generation is like this, one generation. This is second generation. Divided by number of fission in previous generation neutron, number of fission produced by you can say preceding number of fission produced by preceding generation. of neutrons. If this is less than 1, if this is less than 1, will size is maintained in such a manner. If it is equal to less than 1, fission reaction will stop, chain reaction will stop. If it is equal to 1, it is critical size. If it is slightly more than 1, then it will continue. So this K number is maintained slightly more than 1. So this is you can read the books, please. Read NCERT book or any other book for more details and more. I can explain you what is happening here. And I hope you have got my point. Actually, I was not able to upload some videos. So I told you control chain reaction. So chain reaction, control chain reaction and control chain reaction. Now I will come to next video about nuclear reactor or nuclear piles and then fusion.